Okay, so remember when we had an exponential function, we said f of x equals b. You have some base to the x, and the base is a real number, but the base has to be greater than 0, and it can't equal 1. That's what we said. So you can have the base be the base could be greater than 0, but less than 1. And something happens when that happens. So here we have a function and the base is 1/2. Okay, so let's think about a table of values here. X, g of x. And the base, now we've seen what happens when the base got larger, like when we went from a base of 2 to a base of 3. We saw the exponential function getting bigger quicker. Okay, but what happens if the base is between 0 and 1? Okay, so let's put in like -2, -1, 0, 1, and 2. Those are all good numbers, right? So what happens if you take 1/2 and you raise it? Let's start with 0. Let's start here. If I raise it to the 0 power, well, that's just going to equal 1, because anything to the 0 power is 1. Okay, what happens if we have 1/2 to the first power? Well, that's just 1/2. And what happens if we have 1/2 squared? Well, remember that's the same as 1 squared over 2 squared, or 1/4. Or you could think of it as 1/2 times 1/2, but you're going to get 1/4. Let's graph those. So 0, 1, and then you have 1, 1/2, and 2 is 1/4. Okay, so look at those numbers getting smaller, right? As x gets larger, we're getting closer to the x-axis. Well, what happens if you put in a negative exponent? Now I have 1/2 to the -2. Well, you might remember a negative exponent reciprocals that base. So 2 over 1 squared, or just 2 squared, which is 4. So -2, 1, 2, 3, 4 is right there. And what happens if you put in a -1? Well, again, it's going to reciprocal 2 to the first power, which is just going to be 2. So -1, 2. Okay? So you get this curve going like this. I could have put in 3 and I would have had 8. Let me do that. Let me erase. Oh man, it erased the whole thing. Okay, so if I put in -3, I have to put in a -3, then I'm going to have 1/2 to the -3, which is going to be 2 cubed, and that's going to be 8. So -3, 8 would be up here. I'm just getting another point, so I could make a better graph. So it looks like that. So it's like that 2 to the x, but it's reflected about the y-axis, right? Now, why does this make sense? Well, couldn't we write that function as 2 to the -x, right? Because it's just a 1 in the numerator. So I could actually rewrite it to look like this. These are the same functions, okay? So you think about that and what negative exponents do. And you could rewrite that. Well, when we have the negative sign in front of the variable, that's going to reflect it about the y-axis. It's before we're applying the function, so that's why it's a reflection about the y-axis and not the x-axis, okay? So the function is 2 to some exponent, but we're changing the sign on the variable first, and then we're doing 2 to that power. So that's why it's a reflection about the y-axis. Okay, so it reflects about the y-axis. And we're going to talk about characteristics in the next video, but that is like a transformation, right? Let's see, anything else with that? No. Oh, it's a decreasing curve though now. Now it's not increasing, right? It's going down, so it's decreasing. Okay.